Hi guys, just a holding well. Welcome to my YouTube channel, TPM Stuck with Holowale. Let's get right into it. In today's module, we'll be discussing technical literacy. Every product manager out there needs to know. So why is this topic quite important, right? Whether for you as a product manager, technical product manager, engineering guy trying to transition into technical product management, every product you will ever manage, every product you will ever build revolve around these core things. How data move across the internet, how backend system are structured, how API system communicates, what is performance, how are data stored across both on the web, on the platform, and even in the database. If you don't understand these basic informations or these basic principles, you will literally struggle in leading your team to achieving something great as a technical product manager. Once you understand these informations, you're able to communicate and speak engineering terms quickly. Furthermore, we've divided this module into three sections. The first section will be discussing how internet works. Under this section, we'll be discussing topics around DNS, IP. And the second section, we'll be looking at backend infrastructure, how backend are being structured, where we'll be discussing monolithic architecture, right, microservice type of architecture. And lastly, we'll be looking at RESTful APIs. Under this section, we'll be looking at RESTful APIs, authorization, authentication, and even database in itself. So let's get right into it. Every time you visit your website or open an application, a few things happen behind the scene. Now let's break it down. We'll start by looking at what IP is, types of IP, and why it matters. According to the definition I have here, an IP address is a unique identifier assigned to every device connected to a network. What does this mean? Now, think about your device as your house address, right? Your house in itself, right? Your street, your house number has the IP address. The data packet is probably the grocery or the meal or even the food item you're expecting. Without an IP address, these informations or this data will not get to you, right? That is why IP address is very important. And as of today, we have two major types of IP. We have IPv4. This is shorter, the older one and the shorter version. And we have the IPv6, right? This is the newer one, and it was basically created when we ran out of IPv4. And why does this even matter for you as a technical PM? It's important for you to understand this because fundamentals of how data exchange happens within the internet, right? How network and basically internet connect to themselves, different devices, how they connect to themselves. Now let's look at DNS. What does DNS mean? Imagine a world where every website you need to visit, you need to memorize the IP address. Instead of probably typing Google, you're having to memorize various numbers of string. It doesn't make sense. That's definitely not user friendly, right? Hence why we have DNS, right? It helps translate those IP address into human readable text or things that are user friendly. And how does this literally work in essence, right? When you go into a website or you probably type in, take for instance, you visit Google, right? Your browser asks DNS, what IP address is this for? Right? Your browser sends that request to that particular IP address and the website loads. That's literally how it works, right? So think about DNX as what's it called? As a phone book on your phone, right? You don't have to memorize everybody's numbers, right? By just typing their name, their number, their information pops up, and you're able to basically dial them in near real time. In the second module, we'll be discussing backend architecture, where we will be looking at monolithic architecture and the microservice architecture. Now, let's talk about what happens once request reaches the backend. Right, let's start by looking at monolithic architecture. According to my definition here, monolithic architecture is a software design where the entire application is built on a single or a unified system. Imagine when you have a very large office, a large office building, and in the large office building, you have a very large hall. In that hall, we have hall departments seated within that hall, right? As a user or as a customer, it will be easy or probably inter-business related self, right? It will be easy when the team is about five. You literally you don't have to walk a distance, right, to even interact with each other or get certain things processed or get certain requests being attended to. But now imagine a world where you now have 8,000 or probably 20,000 teams. Everyone's still seated within that same hall. Request now gets longer to even work, right? For you to even get this request processed, you have to walk down looking for where what department is, where they are, and even getting them to even assist you, right? That process becomes tedious, right? And what you will see when you experience that is request time takes longer, right? You're not able to get things done efficiently, and just it's the same way it works with application. When your application is built on a monolithic architecture, right? It's easier when you have probably 1,000. You are managing 1,000 customers. Now imagine when your customer base goes to about 10 million, right? And everybody is basically eating the same application. Every request route through every of those departments, everybody within the single component. Just a single break in one component of that application, right, will break down the entire app in itself, right? So it's no longer efficient, right? That's when you click on application, some application it takes forever to load, right? It becomes buggy, it becomes non-responsive. So let's look at the advantage. However, it has its own advantage, it has its own disadvantage. So let's get right into that. According to what I have here, right, the advantage of a monolithic platform is it's simple to develop, right? Easy to design. It's easy to design code and test, right? You can basically use it for a small project, like I had mentioned, maybe when your customer base is around just 1,000, you're trying to test your idea. You don't know how big it is, so you don't want to invest a lot in the architecture when you don't know if the product is going to be a success or not, right? So it's literally used for when you want to test out project fast, right? Or you want to build something, majorly your MVP. It's also easy to develop. It's straightforward debugging because at the end of the day, everybody is within the same component, right? You're able to literally figure out what is wrong with the app, right? But it has its own downsides, right? Some of the disadvantages is hard to scale, like I had mentioned, right? When you business go to about 10 million users, that 5 room department or that single building that takes about that is able to cater to 100 people's need, right? That single room might not be able to cater to 1 billion or 100,000 customers needs anymore, right? It's also difficult to maintain and grow, like we mentioned, right? Just a single component of monolithic architecture being down, right? It literally makes the whole of the application unaccessible, right? So they're tightly coupled. Just a single breakdown in one causes a major breakdown in the app, and you figure out your customer cannot use your service, right? And you can't even process customers' requests as well. Now let's look at the second most common type of architecture, which is the microservice architecture. According to what I have here, microservice architecture is a software design approach where application is broken into small project and independent service. What does this mean? Right? Let's use the same similar example of a hall or probably a banking building that we had just earlier. Right now, in this banking building, they're no longer they're moving. They've seen how inefficient putting everybody in the same hall is, right? So they decided to split everybody by department, probably by floor. Right? Imagine the building is about four-story buildings. Right? People on the down floors are customer care, the teller guys. Right? First building, right? The first building you have the legal, you have operations, you have treasury. Like you just have these different departments splitted across board. So it's easy to manage. When a customer walks in, you're asking, oh, what do you want? And you're able to quickly route the request there because and you're able to point them to where they will be able to get attended to in real time, right? And queries and it becomes more efficient, right? Your system is now able to handle a large number of customer, a large number of requests. Not everybody is on the same queue, right? We have different departments attending to different customers, right? So the same way it works with application, right? We have a service that basically speaks to your profile, right? When you're checking your profile, right, it's talking to a service, right? When you're also doing a transaction, when you want to do a transaction, it's probably talking to another service, right? So you're able to see how just within a tip of milliseconds, when you click on something, you're able to get faster response because you have different departments attending to you, right? That's the way microservice basically works and how it's being structured. It ensures accuracy, independence, and efficiency across board. So let's look at some of the advantage and also some of the disadvantage of microservice in itself. According to what I have here, right, they are highly scalable, right? Easy to maintain, right? Different departments are able to attend to their needs. So even the other thing here is that once, even if a feature is down, it does not mean the whole app is down. Right? You can go into your bank application today and probably trying to make a transfer and the transfer feature is down. It does not mean you still not be able to check your transaction history or probably do a top up on your wallet system or even check your profile or even probably access loan services. Just one component of it is down. It does not mean a single point of entry or a single point of break, right? Collapse the wallet, the system in itself, right? Some of the disadvantages, it can be complex, right? And one of the majors where, in my experience, we have seen a lot of challenges around there is data exchange, right? Because we have different departments. We've built out all of these services in different departments, right? And data exchange becomes a problem because the way party A of feature B has structured this data might be different from the way feature C has also structured this data. So when there's a need for handshake to happen, we need to start doing a lot of refactoring, right, to ensure one-to-one mapping of data. Right, you see certain feature or certain services using microservice, you see others using Google Cloud, you see others using MySQL, you see others using spanner services, right? So when data exchange needs to happen, then it becomes tedious or very, very complex to handle. So lastly, in this section, we'll be looking at caching fundamentals. What is caching? According to my definition here, caching is the practice of temporarily storing frequently accessed data in a fast storage layer so future requests can be served more quickly without computing or refetching those data from the database in itself, right? So what's the goal of caching? Speedy response. That's just the whole thing is doing. So instead of you having to go to a very long distance to fetch information, right? Don't forget now, let's think about it from a tech perspective. Every request you make, every button you click on your website or on a mobile application, it sends a request somewhere. And that request sent somewhere is being fetched from a database, right? Take for instance, you load your mobile application, your fintech application, you're trying to check your balance. That balance isn't stored on that phone, it's stored in a database. You have a profile on their database, right? So when you click on check your balance, it sends that information to a database, right? And before you can access that database, it takes a numbers of steps, right, for you to even access it or even get some of this information, right? That's where caching basically comes in place. There's certain information on your application or on your mobile application or your website today that does not necessarily change a lot. A typical example is your profile, right? When you open your profile today, your name will most likely not change, right? The profile picture you've set will most likely not change, right? So those are the type of information being cached, right? So when you go into the information, those kind of profile or those kind of features, the application does not necessarily need to send information to the database. It usually stores it in a cache database, so it's able to provide you that information in near real time, right? And it helps increase efficiency of the platform, the response time, and also save cost, right? Imagine when you're going into the database, right? Take for instance, the database is like from point A to point B, and the longer it takes, right, you're also incurring costs on your infrastructure, right? So caching also helps you reduce all of that capability, right? We have two types of caching today. We have the client side caching and also the server side caching. What does the client side caching mean? These are the caching kind of things that basically happens on your website, right? When you're saving, what's it called? I guess you must have seen scenario where you're inputting a password, right? And your screen pops up to asking you, oh, do you want to save this password, right? And you probably say yes or no. When you say yes, that information is being cached on your system. So when next you want to probably visit that website, instead of you having to memorize or input your information manually, right, it basically goes fetch that information for you from where it has been saved on your device, right? It's not saved in the database now. It's basically on your device for easy access. Right, so those are where we use caching on the client side, and on the server side, right? These are like I had mentioned, right, where I use this scenario of profile pictures, right? Instead of having to go into the database to fetch such information, right? It's being cached somewhere for easy access, right? Typical example of how caching basically works, right? When you hit a link, it basically checks the cache first. If it can't find that information in the cache, then it makes another request to the database to go fetch it. And once those information is being fetched, it saves this in the cache for next time. Like when next you need that information, instead of it going back to the database, it can always fetch that information from the cache, right? So that's literally what this diagram is trying to explain. Now let's go into the last module of this course, where we are talking about RESTful API authorization database. So what's RESTful API? RESTful API is an architecture style for building APIs. It allows systems to communicate using standard HTTP verbs or methods. Now, what does this verb mean? APIs generally communicate using these verbs, but not limited to these verbs I'll be calling right after now. Right? We have the get. Get verbs help to retrieve data. Right? I think I'll just explain that at a later time. Right? Let me go over the meaning of those verbs. Right? We have post. Post helps you to create information, and we have put. Put helps you update the information you have about yourself. Right? And we have delete. Right? Delete helps to remove certain information from the database. Now let's practicalize this. What does this mean? Every time you click a button to perform an action on the website or on your mobile phone, it's either some of these API verbs is being called. Take for instance, when you're trying to create an account, probably you find an application interesting and you want to create an account with them. When you click create an account, right, on that link in itself is embedded a post, right? So you can probably see an example of what we have here. You can see an example of what we have here is where you have this, where my cursor is, you have post slash user dot 123. It's creating a request for you, right? It's creating a new user in the company's database or in the platform database. All right. When you go into the same application, right, and you want to get your, probably you open a wallet in a fintech application and you want to see your wallet balance or your balance, right? When you click on show balance, right, you have get slash transaction balance or something, right? On that button show balance is embedded the verb call get slash xyz, and we'll be looking at API structures and API testing at a later time, right? But when you click on show balance, it's embedded in that button is the get HTTP verbs, right? It helps you retrieve certain information, right, from the database, right? So you get tired of the application in itself, right, and you don't want to use the app again, and you go into your settings and you want to delete the application, right? When you see that delete button, right, embedded on that delete button is what we have, the delete URL, right? Delete slash user slash xyz. Once you click on that delete, it sends that information to the database, saying that this customer wants to delete his information, right? And its actions is based on your instruction, right? So you don't probably like your profile picture on your WhatsApp or whatever it is. When you click on that button, change profile picture, right, the endpoint embedded in it is the put, where you want to update certain information. So it sends certain information to the database saying that, oh, this is what the customer, this is what exists today. Can you change what exists today to this? This is what the customer wants. Then it takes a few minutes. That's where you get to see your system load and you get to see a success screen, right? That information has been passed out, right? So what the RESTful API does is it ensures that every button you see today is able to send the accurate information to the database, right? Everything about you today, right, is being stored in the database, right? No information, right? Imagine where you probably did not use a website, you didn't use a profile picture. So the company cannot manufacture data for you, right? So you're able to use all of those informations, right? The get, the retrieve, the put, right? The delete, to maneuver or update your information as you please it, right? Within the database. Now let's talk about API authentication, the basics, right? According to my definition here, API authentication is the process of verifying who is making an API request and determines what they are allowed to do. Without API authentication, what happens? APIs are vulnerable to abuse. Sensitive data can be exposed, right? Imagine imagine you have a house right, and you don't have a key, right, to the house, right, it means anybody can literally come in and out of your house, take whatever they want, right, without your permission, right. So API authentication helps you in preventing that, right. It serves as a gate. Those are kept secured and they are accurate, right. Nobody can go into your information and basically maneuver your information or probably change it except your system is being hacked. But we will look at that at a later topic, right. What are the types of API authentication we have today? We have the username and the password, right. That's the kind of information where you go into your system and on the API level, you input the username and the password, right? We also have API keys. This is basically on the technical side, where before you can even access the complaint properties, right? Access complaint resources, right? You are required to have API keys, right? They generate tokens to you. We also have JW tokens, right? Is another one where we also have OAuth 2, right? This is, I guess, you must have seen scenarios where you go into an application and they're asking you can choose whether you want to sign it via Google, Facebook, or Instagram or Twitter today, right? That is basically powered by OAuth 2 kind of authorization or and authentication. Now let's look at database, right? Lastly, we'll be looking at database. We have two types of database today. We have majorly two types of database. We have relational database and non-relational database, right? Depending on the type of application you want to build, right? It also determines the type of database you will use. Right? We have the relational database where an example of that is MySQL. We have Postgres, right? On relational database, we have MongoDB, right? We also have DynamoDB, right? Today it depends on literally, right? They are all good, right. They have their own use case, they have their strength, they have their weaknesses, but depending on the type of project you want to build will help determine the database you want to know. But it's important for you as a TPM to understand that there are two major types of database: the relational database and the non-relational database. All right, thank you for joining us today. See you in our next class.